Going to prove a nice theorem today. The LCM of AB times the greatest common factor of AB is equal to A times B. And LCM is the least common multiple. Proof. So A is made up of, is a product of prime numbers raised to various powers. Well, let me say it this, sorry. A has is made up of prime factors, and so is B. Okay, let P1, P2 up to Pn be the combined prime factors of A and B. Let me be clear what I mean by that. If A is 2 to the 3 times 3 squared times 7, and B is 2 times 3 squared times 91, then I'm using above 2, 3, 7, and 91. 2, 3, 7, 91. Those are the primes I'm using. I put them together. So, for the record, A would have these primes. It would be 2 cubed, 3 squared, 7 to the 1, but 91 would be raised to the 0. Likewise, B would have 2, 3, 7, and 91. It would be 3 squared, 91 to the 1, 2 to the 1, but 7 to the 0. Okay, a lot of these powers that I'm about to write for the primes might be 0. Or some of them might be 0. Okay, so A is equal to first prime to some power, call it R1, times prime 2 to the power of R2, prime 3 to the R3, all the way up to P sub n raised to the R7. And B is going to be same primes, but maybe the different powers. P1 to the S1, P sub 2 to the S sub 2 power, P sub 3 to power S3, all the way down to P sub n to the S sub n power. Now, the least common multiple of AB. How do you find the least common multiple? Well, you take the factors, the prime factorization of A and B, and you take the largest power from them. Okay, from these primes, P1, you take the max of R1 and S1. And you do this all the way down to P sub n, and you take the max of Rn and Sn. Now, for the greatest common factor, it's the reverse. You take not the max, you take the min of these two. Take the min of R1, S1, all the way down to P sub n, and you take the min of the two powers of P sub n. Remember, some of those mins might be 0. R sub n, S sub n. Now, if you happen to multiply the two, you multiply the LCM of AB by the GCF of AB, naturally you will get this times that. So you're going to get P1 to the max of R1 S1 all the way down to P sub n times the max of Rn Sn times P times the GCF, which is P1 times, well, let's see, you'll get this times what I'm about to write. P1 to the min of R1 S1 all the way down to P sub n to the min of Rn Sn. Okay. Now, when you multiply and you have like bases, you can add the powers. So we have P1 to some power times P1 to a power. So we're going to get P1 to the sum of those powers. The max of R1 S1 plus the min of R1 S1 all the way down to multiplying those. They have like bases, P sub n. So we add the exponents. We get the max of, the max of, R sub n Sn plus the min of R sub n S sub n. Okay, now let's see what this equals. What's the power of P1 going to be? Now, let's suppose that R1 is the largest. So this will be R1 and plus, and that would be S1. So we will get R1 plus S1. Or wait a minute. What if that was the largest? So then that will be the least, the min. So you get the sum, which will be S1 plus R1, which is just what I wrote. But wait a minute. What if they're the same? So the max of this would be R1, and the min of this would also be R1, but R1 is also S1. That is, they're the same. They're the same. The max of 3 and 3 plus the min of 3 and 3, well, we have to add. The max of this is 3 plus the min of that is 3. So we just add them. So no matter how we do it, we keep getting that the power is R1 plus S1. And we continue doing this. For P2, the power is going to be R2 plus S2. All the way down to P sub n times. All the way down to P sub n Rn plus Sn. Okay, we're almost there. This is the same as P1 to the R1 times P1 to the S1 times this. Well, that's P2 to the R2 times P2 to the S2. All the way down to Pn to the Rn times Pn to the Sn. Remember, if you multiply and the bases are the same, you get this common base and you add the exponent. And that's just what I'm doing. I just undid it. Alright, now this times this all the way down to this, no plus times. All the way down to Pn Rn times, now I'll multiply these. And that's going to be P1 to the S1 all the way down to Pn to the Sn. And you say, oh, that's what we called A times O. That's what we called B. Let's just see it. Yep, right here. That's what A was. And B was a product of those primes where the powers were S. So yeah, we did get AB, and that completes the proof. Watch and learn. See you in the next video.